Hi guys, today we're going to learn about the extrema on an interval. Let's start with the definition of extrema. Let f be defined on an interval I containing c. We have that f of c is going to be the minimum of f on the interval if f of c is less or equal than f of x for all the x's in the interval. Similarly, we have that f of c is the maximum of f on the interval if f of c is greater or equal than f of x for all the x's in the interval. The minimum and maximum of a function on an interval are the extreme values, or what we call the extrema of the function on the interval. The minimum and maximum of a function on an interval are also called the absolute minimum and the absolute maximum. In other words, this is also called the global minimum and global maximum on the interval. So if you see absolute or global, they mean the same. Now, let's go over the definition of a relative extrema. If there's an open interval containing c on which f of c is a maximum, then we say that c, f of c, this point is called the relative maximum of f, or you can say that f is a relative maximum at c, f of c. Similarly, we have that if there's an open interval containing c on which f of c is a minimum, then the point c, f of c is called the relative minimum of f, or you can say that f has a relative minimum at the point c, f of c. We say that the relative maximum and relative minimum points are sometimes called the local max and local min points respectively. So let's look at an example here, and you can see that it's pretty straightforward. So in the figure to the right, we have the interval -2 for including the extremes. Let's shade the extremes, okay? So you can see that this beautiful curve, f has, let's call it f, okay, has an absolute maximum where? Absolute, it means the highest point. So the highest point here is going to be the 4,21. Similarly, we have that f has an absolute minimum, meaning the lowest point, at -2, -15. Okay? Now, we say that f has a relative maximum. What is a relative maximum? Here being a little bit not elegant, it's pretty much the top of the mountain, okay? The top of the little mountains that we have, that in the future we're going to do a more elegant way here. But here you have that it's going to be the 0,5. Similarly, f is the relative minimum, or you know the lowest point of the hill here, which is going to be, in this case, 2,1. We're going to look later about the first derivative test, and that will define this more elegantly, okay? So for now, we have the definition of a critical number and a critical point, that they tell you that you have f, that it's defined at c, okay? So if f prime of c is equal to 0, or if f is not differentiable at c, then we know that c is a critical number of f, and the point c, f of c is what we call a critical point of f. Okay? So we have a little theorem here. Relative extrema occur only at critical numbers. So let's look at the examples here so you can see that all of this is pretty straightforward. So in the following examples, what we have is you need to name the maximum and minimum points if possible. So let's look at this one. This one, we have all the continuity function here between this and this, that it's -1 and 2. Okay, so you can see that the lowest point here is this point, which in this case is going to be the point 0,1. Similarly, you can see that the maximum or the highest point here is going to be this one, which you can see that it's going to be the point 2,5. Okay? So you're all happy, you are like, I'm getting this. Now, let's complicate things a little bit more. Here we have a hole, okay? So you're all happy, you are like, I can find the minimum, it's at 0,1, and you're right. And then the maximum, where's the maximum? Well, that one is not a maximum because that's not defined on the function. So technically speaking, it's none, okay? Similarly, on the third example that we have over here, now that you were very happy with the minimum, boom, they give you a hole there. So the minimum is going to be at none, okay? The maximum is going to be this point that you see over here, that it's the point 2,5, okay? So what conditions are necessary to guarantee that there will be a maximum or minimum? So what we know is that the function, okay, needs to be what? Needs to be defined defined there. Otherwise, if you don't have a function, can you find a max or min? Absolutely not, okay? So the extreme value theorem tells you that if f is continuous on a closed interval AB, then f attains an absolute maximum value of f of c or absolute minimum value of f of d for some numbers c and d inside the interval AB. So what are the guidelines to find this famous extrema, or what we call the candidates test? To find the extrema of a function f on a closed interval AB, we need to follow the next steps. Step number 1, you're going to find the derivative and you're going to equalize it to 0 to find the critical numbers of f in AB. After that, you're going to evaluate f at each of the critical numbers that it's inside A and B. Third, you have that f needs to be evaluated with the endpoints, so you're going to take each of the endpoints into f, and then you are going to evaluate them. Then you are going to compare a bunch of the outputs, and then the least of these values is going to be the minimum and the greatest is going to be the maximum. So how does it look like? Let's use some examples here so you can see that it's pretty user friendly. The first thing that you are going to do here, since they are asking to find the absolute max and mins of f in the closed interval, okay, and state where this occur, what you're going to do here is you are going to take the derivative of your function, the derivative of that function, 3x squared minus 24x minus 1, in the interval negative 1, 5, you have that it's going to be 6x minus 24. Immediately after finding the derivative, what you're going to do is you're going to equalize that to 0, and you're going to solve for x. You solve for x, you know that 6x is equal to 24, therefore you have that x equals 24 is going to be your critical number. Okay, so you have your critical number here. So what are we going to do now that we have the critical number? What I do is I create this beautiful table so I keep everything organized and very simple for me, okay? So you can see that here I have my table. So what's the business here? What you're going to do is you're going to put the candidates. That's why they call it the candidates test. What are the candidates? Negative 1, your critical number 4, and the other extreme that it's 5. Okay? What are you going to do with these values? You're going to plug it into f, the original. So you have that it's going to be 3 times negative 1 squared minus 24 times negative 1 minus 1. This is going to be equal to what? That's going to be equal to 26. Similarly, you are going to do the same for 4. You are going to plug it into the original, as you can see here, okay, minus 1. And this is going to be equal to what? You know that this is going to be equal to negative 49. Following the same trend, you are going to plug the 5 here, okay, into your original. And you have that this is going to be equal to negative 46, okay? So what you're going to do here is you're going to compare all your outputs, the 26, the negative 49, and the negative 46. Which one of these three is the greatest? Well, that's 26, so that's going to be your max. And what's going to be your min? It's going to be the lowest, okay, which in this case is negative 49. So that's your minimum, okay? So now the only thing that we need to do is conclude. So we know that by extreme value theorem, or EVT, you can also say by candidates test, f has an absolute minimum, okay, at the point, what's the point? 4, negative 49, okay, and an absolute what? An absolute maximum, right? At what? Where's the maximum? Negative 1, 26 on the interval negative 1, 5. And that's pretty much it, okay? So that's what we have. Remember to justify always your answer with the theorem that you're using, the function that we have, and then obviously what they are asking, that it's the max and min. Okay, so let's do another example so you can see that it's pretty user friendly. Okay, so the next example that we have over here is f of x is equal to 6x cubed minus 6x power 4 plus 5 in the interval negative 1, 2. So what are you going to do here? Again, you're going to take the derivative. Okay, so you're going to take your derivative here, so you know that the derivative here was going to be that 18x squared minus 24x cubed plus 0. You are going to equalize this to 0, since here we can factor it beautifully, the 6x squared times what? 3 minus 4x equals 0. You know that you are going to equalize each factor to 0 and solve it, so you have that these two are going to be your critical numbers. Okay. Similarly, we have our critical numbers. They don't match with the extremes, so we have 4 candidates in this situation. Okay. So your candidates here, let's look at them and let's evaluate them. Okay. So you have x and f of x. So you have -1, you have the 0, the 3 over 4, that is not going to be pretty, and then you have the 2, right? Okay, so these are our candidates. What are you going to do here? You're going to plug them into the original. So it's 6 times -1 cubed minus 6 times -1 power 4 plus 5. And this is going to be equal to -7. Okay, similarly with the 0, you know that that's 5, but this one is not going to get pretty with the 3 over 4. Okay, this one is not very fun. Okay, look at those numbers, hideous. Okay, so we have that it's 721 divided by 128, which is, because I plug that value in the calculator, I know that it's roughly 5.632. Okay, so I'm doing it so you can compare it with the numbers. Then the 2, you plug the 2, right? 2 times power 3 times 6 minus 6 times 2 power 4 plus 5. So you have that this is going to be equal to -43. Okay, so you compare your values. You have -7, 5, positive 5.6, whatever, and -43. So you can see that this one is the highest number, okay, and this one is the lowest number that you have. Okay, so let's conclude by extreme value theorem. Okay, f has an absolute minimum, okay, at the point 2, -43, okay, and an absolute maximum, right, at where's the maximum? 3 over 4, that horrendous number that we have, okay, on your interval, and the interval is -1, 2, okay, and that's your conclusion for this problem. So let's look at this example. It seems pretty nice, pretty short and friendly. Let's see if it's that friendly. So you have the function f of x is equal to 3 times x to the power of 2/3 minus 2x plus 1 on the interval -1, 8. So you're like, I think I'm getting it. I just take the derivative. You're right. So that derivative, beautiful, the 3's cancel. So you have that it's 2 times x to the power of -1/3. And then you have -2. Then you equalize this to 0, right? But think about something. We're equalizing this to 0, okay? Back when we were looking at the definition, you know that a critical number is what? When the derivative is equal to 0 or when the derivative is undefined. This being undefined, look at this. This becomes a 0, so you can discover that before we do this, okay, before we solve this, I have a critical number at x equals 0. Why? Because that makes your derivative undefined, okay? So this 0, it's a 0 because the denominator, what happens when you have 2 over 0? Undefined. Is the 0 inside the interval? Yes, it is. Therefore, this is a critical number even though I haven't solved that situation, okay? After that, you continue solving this, so you're going to have something that looks like this, right? So you have that x is equal to 1. Do you see it? So this is a critical number, but this is also a critical number. Okay, so in this situation, we have these two beautiful critical numbers and, of course, the extremes that they are given to you from the hypothesis of the problem. So you have f, okay? So we have -1, we have 0, we have 1, we have 8, okay? So you plug the -1 there, so you have -1 squared, and then the cube root, and then you have the -1 here plus 1, okay? So we have that this is 6. Similarly, when you plug the 0, that's a 1. When we plug the 1, that's more natural, right? Okay, so you can see that this is going to be just 2. And then you're going to tell me, oh, this number is horrible. Well, actually, it's not that bad, okay? So because if you see it, this is going to be 2 squared, that's 64. What's the cube root of 64? That's 4. 4 times 3, that's 12. Okay, so you can see easily that you have 12 minus 16 plus 1, that's a negative 3. Okay, what happens here? Look at the numbers 6, 1, and 2. Negative 3, excuse me. Which one is the highest number that we have? This guy. What's the lowest number that you have? The negative 3. Okay, that's a min. Okay, so by extreme value theorem, what do you have here? We know that f has an absolute what? Min, right? At the point 8, negative 3. And we have an absolute max, right? We have an absolute maximum at the point, where's my max? Negative 1, 6 on the interval negative 1, 8. And that's what we have for this problem. Okay, so let's look at the last problem of this set. We have a beautiful trig problem here. F of x is equal to sine square x plus cosine x on the interval 0 to pi. So as usual, remember when you see this, what I'm seeing, if you are still having some little issues with the chain rule and the power rule, look at this as this. Okay, so if you look at that function as the following, you know that you are going to use the power rule. Then this is going to be sine of x to the power of 1 times the derivative of the inside, which is cosine x, minus sine of x, because the derivative of positive cosine x is negative sine of x. Now, you don't have any on definition here because the sine and cosine functions, they behave beautifully, and you know that the domain of those two are all real numbers. So equalize this to 0 to find your critical numbers. You are going to tell me, how in the world I'm going to do that? Well, you took pre-calc before this class, therefore you can see that here you have a pre-calc problem. Okay? So what are you going to do? You're going to factor out the sine of x, then you have 2 cosine x minus 1 is equal to 0, and then you are going to equalize each one of the factors to 0, and using your unit circle knowledge, you can solve this. When sine of x is equal to 0, you know that that's true in the interval 0 to pi, at 0, at pi, and 2 pi. Similarly, you are going to ask yourself, okay, so this is, technically speaking, cosine of x is equal to 1/2. When my cosine in my beautiful unit circle is equal to 1/2. That's going to be at pi over 3, 5 pi over 3. So now we have all the critical values here, all the critical numbers, excuse me, because the values are with everything, so critical numbers. Okay, so what are the critical values that we have? Well, let's look at the x's. Let's start with 0. Okay, then we have pi over 3. As you can see, I like to go from the smallest to the biggest with the x, so it's a little bit organized, but you can do whatever you want, right? And then we have 2 pi. Okay, 1, 2, 3, 5, 1, 2, 3, 4, 5. Okay, so we have all the values there. Okay, so you are going to plug them where? Into f of x. Okay, in this situation, you know that what's going to be sine of 0 square plus cosine 0, you know that that's going to be 1. Okay, then you know that sine of well, I'm going to write it here, sine of pi over 3, okay, is going to be root 3 over 2, right? Square, that's going to be what? Technically speaking, you have a 3 over 4 plus 1/2, so you have 5 over 4. Okay, so knowing your unit circle, right? Then with pi, you know that this is 0, but this is negative 1, so that's negative 1. Actually, this is 1 because it's the same value as 0. This guy is going to be a little bit different, right? The only thing that it's different, it's not going to affect anything, is the fact that you know that sine of 5 pi over 3, what's sine of 5 pi over 3? You know that it's going to be negative root 3 over 2. But since you have the square, that's going to be 3 over 4 plus 1/2. So you again have 5 over 4. Okay? So you compare the values. You have 1, 5 over 4, negative 1, 5 over 4, and 1. Okay, so the absolute mean, it's pretty easy to spot. You can see that this is the mean, but you are going to tell me, oh no, can we have 2 max? Yes. Okay, why not? Think about the sine and cosine function. Yeah, you can. Okay, that's possible. So just conclude by extreme value theorem. What do you have? Extreme value theorem tells you that f has an absolute mean okay? At the point, what was our point for the mean? Pi comma negative 1 and 2 absolute maxes, right? Absolute max at, what was my first one? Pi over 3 comma 5 over 4 and 5 pi over 3 comma 5 over 4, okay? And you are finding all this on the interval 0 to pi, okay? And that's pretty much it, okay? I hope that you find this video helpful. Bye.